Hi guys, and welcome back to another series, parallel circuit. In this circuit I will be showing you how to redraw a circuit like this and how to always calculate the correct total resistance. In previous videos I did explain to you how to calculate a series circuit, a parallel series circuit, and how to redraw a complicated circuit like this. I also showed you how to use the formulas to be able to calculate a circuit like this. Now let's get started on this one. The main thing here is to first analyze the circuit, see what you have. Where do you have series sections like that one, for instance? Where do you have a parallel section like that one, for instance? And that is going to be your starting point on solving a circuit like this. So what I want you to do is maybe pause the video, take down the circuit, and also as I go along, take down the redrawn circuit for this specific one. Alright, so let's get started. My first section that I'm going to concentrate on will be that one there. There I can see that R3 and R4 is connected in parallel. So my formula will look like this. I'm going to say that R parallel 1 is equals to R3 multiplied by R4 over R3 plus R4. And I'm going to get that that will be 21 over 10, which will give me an ohms value of 2.1 for those two resistors. Next, we're going to go to the redrawn circuit, which is the first one. There I have my first redrawn circuit, and here I can see that R3 and R4 is parallel, R parallel 1, which I have here, and that is now connected in series with R2, which is the 4 ohm resistor. So the next one that I will do will be this one, and I will call this one RS1. So RS1 is R2 plus RP1, which will be 4 plus 2.1, which will give me a total resistance of 6.1 ohms for those two resistors. Let's go to my second redraw. In my second redraw, we can now see that R2 and RP1 is now RS1, which is now connected in parallel with R5, and that will be my second parallel section, which I will solve. And we can say that RP2 is equals to RS1 multiplied by R5 over RS1 plus R5, which will give me a total value of 3.461 ohm for these two resistors connected in parallel. Let's go to my third redraw. In my third redraw, I can now see that RS1 and R5 is resistor R parallel 2, which is now connected in series with my R1 resistor. So that is going to be my second series section, which I will solve. And that will be RS2 is equals to R1 plus R parallel 2, which is equals to 5 plus 3.461, which will give me a value of 8.461. Let's go to my fourth redraw. In my fourth redraw, we can now see that R1 and R parallel 2 is resistor RS2. Now resistor RS2 is connected in parallel with these two resistors, which is connected in series, which is R6 and R7. So we need to solve these two first, which means that is going to be my third series section for this specific circuit. And that will be RS3 is equals to R6 plus R7, which will be equals to 10 plus 4, which is equals to 14 ohm. Let's go to my fifth redraw. In my fifth redraw, we can now see that R6 and R7 is now RS3, which is the 14 ohm resistor. Now we can see that we're actually sitting with three resistors connected in parallel. But what I like to do is I like to show you when I have 3 or more resistors in parallel, I like to do them 2 at a time. So the first 2 resistors that we will solve will be RS2, which is connected within parallel with RS3. So those are the first 2 that I will solve. So that will be my third parallel section, and that's going to be RP3 is equals to RS2 multiplied by RS3 over RS2 plus RS3, and that's going to give me a value of 5.274 ohm, which means these 2 resistors together is 5.274 ohm. Let's go to my 6th redraw, and there you can see that RS2 and RS3 is resistor R parallel 3, which is my 5.274 ohm resistor. And now I have 2 resistors which is connected in parallel, which is the last 2 resistors. And now I'm going to say that my R total is equals to these 2 resistors. So finally, because it's my last 2 resistors, as I've just said, it's going to be R total is equals to R parallel 3 multiplied by R8 over R3, RP3 plus R8, which will give me a total resistance for the whole circuit of 2.567 ohms. And that, guys, is how you calculate your total resistance and how you redraw each section which you calculate, so that you will always be able to calculate the correct total resistance. Next, we will calculate my total current. So guys, to calculate the total current of the circuit, what do I need? I need the total voltage, and I need the total resistance, which I've just calculated. So my I total in this case is then V total divided by R total, which is the 20 volt divided by 2.567, which is my total resistance for the circuit, and I'm going to get a value of 7.791 amps, which is the total current flowing in the circuit. Alright guys, so the next thing that I'm going to show you is how to calculate currents in branches. I'm going to calculate what is the current I6 flowing in this branch here. I'm also going to calculate what is the current I8 flowing through R8. The first thing that we need to understand when we do this and when we calculate currents in branches is we need to understand the theory behind the circuits. Because if you don't understand the theory behind the circuits, you will struggle to calculate what is the current flowing through this branch, for instance. If you understand that, then you will know that although these 2 resistors are connected in in series, both of them are connected in parallel with my battery, which means if I add these 2 together, or if I combine them like I did when I calculated the resistance, it means that the voltage drop over that one which I calculated there, which was RS3, then the voltage drop is 20 volts over that specific resistor. So I'm going to go to that redrawn circuit, which was the 5th redraw, and there I can see that RS3 is equals to 14 ohms, which means to calculate the current flowing in that branch there, I'm going to say that I6 is equals to 20 volt divided by RS3, which is the 14 ohm, and I'm going to get what is my current flowing through that branch, which means what is I6. What am I actually telling you? I'm telling you that the voltage drop over that resistor, which is R6 and R7 combined, is 20 volt because that resistor is in parallel with my battery. So let's do that one. And I'm going to say that I6 is equals to my V total divided by RS3, which is the 14 ohm. And I'm going to get that the current I6 flowing in that branch is going to be equals to 1.428 amps. Next, I can calculate what is the current flowing in this branch. And the same thing. My 8 ohm resistor, or sorry, R8, which is the 5 ohm resistor, is in parallel with my battery, which means the voltage drop over that resistor is also going to be 20 volts, which means I8 is equals to V total divided by R8, which is the 5 ohm resistor. So let's do that one. And now I can say that I8 is equals to V total divided by R8, which is 20 divided by 5, which will give me 4 amps. So there's a total of 4 amps flowing in that branch there. And another thing with what you can do is to figure out if you have worked correctly in the sense of the currents. And remember, our total current was 7.791 for amps for the circuit. So meaning if 4 amps flows in that branch there and 3.791 amps flows that way, if you add the two together, you will get 7.791 amps again, which means you have worked correctly. The next thing that we will do is we will calculate the power dissipated by this specific resistor, which is the R8 resistor. Now the thing about calculating power is you can use 3 power formulas, or there is 3 power formulas that you can use to calculate the power. Let's use only one of them just to show you what you should get, and you can try and use the other 2 formulas and see if you get the same values. So the formula that I'm going to use is the one that says PR1, which is the power in the resistor R1, which is equals to my V total multiplied by I8, which is going to be 20 multiplied by 4, and that's going to give me 80 watts. So the power absorbed or dissipated or used by this specific resistor is 80 watts. Okay, right guys, I've come to the end of the video. I hope you enjoyed it and you understand it, and I hope you followed what I did in the circuit. So please stay tuned. There is more of these types of videos coming. So if you would like to get a notification, subscribe to my channel and be ready for the next one. Thanks for watching.